As from the 1st of January 1993, regulations will be enforced which require electrical contractors to test their own work before its permanent connection to the supply. This means all contractors must become fully familiar with the methods of testing. The new regulations mean that supply authorities will no longer be required to inspect 100% of the notified electrical work. This percentage will drop to 90 by the end of the first year and then progressively reduce to 50% over 5 years. The electrical contractor will be responsible for the actual testing, while the electrical inspector may inspect the installation but not necessarily test it. To date, the principles of electrical circuit testing have not been taught as a separate component of the electrical trades course, but the fundamentals of electricity still apply to testing. There are precise techniques which the installing electrician will need to use competently. This video aims to inform those responsible for testing and certifying electrical installations so that they comply with the relevant requirements of the testing guidelines. This program is divided into 3 segments. Part 1 deals with the test requirements, the range of test equipment, and the 9 mandatory tests. Part 2 provides a recommended test sequence and flowchart for a complete installation when supply is either available or unavailable. Part 3 deals with the testing of submains. So let's begin with the test equipment and the purpose of the individual items. Essential test instruments and equipment include an insulation resistance tester and an ohm meter. These may be separate instruments or a single instrument incorporating both functions. Both digital and analog types are available, and the choice of which type to use is left to personal preference. However, if an analog type ohm meter is used, it's recommended that it should indicate 2 ohms at not less than 25% of full-scale reading. In the case of the insulation resistance tester, it must be capable of maintaining its rated output voltage when testing a circuit or equipment with an insulation resistance of 1 megohm. Most modern insulation resistance testers will meet this requirement, but older equipment, such as the hand-wound generator type, should be checked before use. And of course, all testing instruments should be tested for accuracy at regular intervals, particularly after extended storage periods or rough handling. These instruments can be checked against a range of standard resistors having a tolerance of plus or minus 1%. Values of 0.5 ohm, 1 ohm, 2 ohms, 20 ohms, 10,000 ohms, 1 megohm and 10 megohms are recommended. Also recommended are Series 415 240 volt test lamps, preferably with fused leads, contact probes for socket outlets and also for lamp holders, both of which can be custom made, a 15 watt lamp, a 60 watt lamp or other suitable item with approximately 70 ohms resistance and a flashing unit. We'll explain the use of these loads later, and we'll also need a trailing lead of insulated cable. Well, so much for the equipment. Now let's look at the test methods as shown in the document Guidelines for Testing Electrical Installations. The 9 tests required are earthing resistance and continuity, insulation resistance, polarity, transposition of neutral and earthing conductors, short circuit between conductors, interconnection of conductors of different circuits, switchboard equipment marking, number of points per circuit, functional operation. These tests will first be demonstrated under the conditions where supply is not available. At the conclusion of that demonstration, we'll show those tests which can be performed where supply is available. Why is this test necessary? Because the earthing system must be installed in a manner that will cause circuit protection devices to operate if there's a fault between live parts other than the neutral and the general mass of earth. An effective earthing system will also ensure that equipment parts which are earthed do not reach dangerous voltages during such faults. What requirements apply? AS3000 generally requires a maximum resistance of 2 ohms for the main earthing conductor. That is, the conductor between the MEN connection and the earth electrode, and also between any point in the installation required to be earthed. For example, points defined as exposed metal, and earth terminals at socket outlets and the MEN connection. In some situations, this resistance must be reduced to ensure that the fault current will operate the circuit protective device. The test procedure requires the main earthing conductor to be disconnected from the neutral link at the MEN connection, so as to exclude the possibility that earth continuity is detected via the neutral conductor. Should the test be performed with this connection intact, Subsequent tests are required, such as shown in Test D, to establish that neutral and earthing conductors are not transposed. First, open the main switch, then disconnect the main earthing conductor from the MEN connection, and then the earthing conductor at the water heater. Disconnection of the water heater earthing conductor ensures that there isn't a parallel circuit via the water piping system during this test. Connect a short lead with a probe to the ohm meter. Connect the probe to the end of the trailing lead to measure lead resistance. This resistance must be deducted from the resistance values obtained during the earthing resistance tests. Now connect the trailing lead between the main earthing conductor at the MEN connection and the ohm meter. Test now for low resistance reading, that is less than 2 ohms. Testing must include, but isn't limited to, the following parts: the earth electrode, the metal water piping system when equipotentially bonded to the main earthing conductor, the metal switchboard surround, and metal supports for aerial conductors. In the cases of metal switchboard surrounds and metal supports for aerial conductors, both of these may be earthed by connection to the consumer's mains neutral conductor, and if so, the continuity resistance test should be made between them and the neutral conductor at the MEN connection. The earthing contact at each socket outlet, the earthing conductor or terminal at each lighting point, the earthing conductor at the water heater. Exposed metal is defined in AS3000 of any fixed electrical equipment, such as a range, oven, hot plates, luminaires, air conditioners and dishwashers. Metal swimming pool parts, where they are equipotentially bonded and connected to the earthing system. For instance, pool ladders, fencing, lamp standards and structural parts of the shell and the deck. When you finish the test, reconnect the earthing conductor at the water heater and the main earthing conductor to the MEN connection. That is, unless you're proceeding to test the insulation resistance as in Test B. Don't forget to deduct the resistance of the leads before recording the results. These tests are necessary because all live conductors, including neutrals and live equipment parts, must be insulated to prevent electric shock hazards caused by inadvertent contact, fire hazards from short circuit, and equipment damage. We test the integrity of the insulation by stress applied by direct current at the following voltages: 500 volts DC for conductors and equipment with a normally working voltage up to 250 volts AC, and 1000 volts DC for higher working voltages. The requirements of the AS3000 are generally a minimum resistance of 1 megohm between earth and live conductors or live equipment parts. This may be reduced for appliances containing heating elements which may have been subjected to moisture absorption, such as water heaters or ranges, provided that a resistance of at least 10,000 ohms is obtained for the appliance as a whole. For the test, we need an insulation resistance tester. The test should generally be performed on the installation as a whole, that is, by connecting all live conductors together, or in component parts by individual submains, final subcircuits, or items of equipment. With the switches on, with portable appliances disconnected from socket outlets, and with the insulation resistance tester definitely not connected between active and neutral conductors, as this can damage any electronic devices such as dimmers and speed controllers that may have been installed. The following test procedure is recommended, although the method may be varied provided that all live conductors and equipment parts are tested. Disconnect both the supply, if connected, the main earthing conductor from the MEN connection, and the main neutral from the consumer's neutral link. Connect the insulation resistance tester between the main earthing conductor and all neutral conductors, either as a group at a neutral link or as individual consumers' mains, submains and final subcircuits. Then all active conductors connected to each phase, either as a group or as individual consumers' mains, submains and final subcircuits as before. Close switches in all circuits. Where two-way and intermediate switching is installed, these switches must be operated to ensure that all conductors are tested. Now test for insulation resistance. a reading of at least 1 megohm is generally required. Reconnect the main earthing conductor to the MEN connection and the neutral link. This test is necessary because an incorrect connection of active and neutral conductors to accessories and equipment is extremely dangerous and has been the cause either directly or indirectly of many shocks and fatalities. People expect that a circuit or an appliance plugged into a socket outlet is disconnected from the supply when the control switch is in the off position. When the polarity is incorrect, parts such as heating elements and lamp holder terminals are live and extremely dangerous. AS3000 generally requires that every single pole switch or circuit breaker operates in the active conductor of the circuit in which it's connected, and that switches or circuit breakers of multi-phase circuits operate simultaneously in all active conductors. In the case of general purpose outlets and other socket outlets which accommodate flat pin plugs, they should be connected so that when viewed from the front of the socket outlet, earth, active and neutral are connected in a clockwise order. For this test, we need the ohm meter and a 60-watt lamp. The test is generally performed on the contacts of socket outlets, contacts of lamp holders or the terminals of their associated switches. It depends on the methods used. Terminals provided to connect equipment such as water heaters, rangers and air conditioners to the fixed wiring. The following demonstrations show how correct polarity can be established when the supply is not available. Earthing continuity has been proved by earlier tests, as in test A, and the MEN connection is intact. A lamp holder is tested by an ohm meter with one probe on a contact and the other to earth. The switch is in the off position. Reading indicates a short circuit at one contact. This is correct. If the switch has been connected in the neutral conductor, a short circuit would not have been indicated at either terminal. Testing a range without supply connected requires an ohm meter, and correct polarity exists if, with switches on, active to earth shows a typical reading of 5 to 15 ohms, while neutral to earth indicates a short circuit. With switches off, the reading should be active to earth 5,000 ohms, typical of a clock, while neutral to earth should indicate a short circuit. Now for socket outlets tested by the ohm meter. First, the neutral conductor of the final sub-circuit being tested is disconnected from the neutral link, and a 60-watt lamp is connected between the conductor and the neutral link. Then, a temporary connection is made between earth and the load site of the final sub-circuit's open fuse or circuit breaker. With one lead of the ohm meter connected to earth, the other lead is connected in turn to the active and neutral contacts of the outlet, first with the switch on and then with the switch off. Correct polarity is proved when, with the switch on, the active to earth indicates a short circuit and neutral to earth indicates lamp resistance. And with the switch off, active to earth indicates an open circuit, while neutral to earth indicates lamp resistance. A 60-watt lamp has a cold resistance of approximately 70 ohms. Transposition of neutral and earthing conductors arises when the neutral conductor is mistakenly connected to the earth terminal of a piece of equipment and the earthing conductor is connected to the neutral terminal. The earthing conductor then becomes the current carrying conductor and is therefore dangerous. The transposition isn't obvious under certain operating conditions, but is unsafe if the earthing conductor becomes open-circuited, causing one side of the conductor and any exposed metal connected to it to become live. The earthing conductor becomes overheated by carrying the load of the larger neutral conductors, or work is carried out on a live earthing conductor. AS3000 requires, under the MEN method of earthing, that the earthing system and the neutral conductor only be connected to a single MEN connection. Testing should indicate that the earthing and neutral conductors are separated throughout the installation and correctly connected to equipment. The test is generally performed on appliances and luminaires connected to fixed wiring, the contacts of socket outlets, and the contacts of unlamped lamp holders. First of all, let's test appliances and luminaires connected to fixed wiring. For this test, The MEN connection should be disconnected and all switches in these circuits must be closed. The ohm meter is then connected in turn between the active and neutral, active and earth, and neutral and earth for each circuit. Correct connection is proved by the ohm meter indicating circuit load resistance between active and neutral, and an open circuit between active and earth and neutral and earth. To test the circuits comprising socket outlets, the neutral conductor of the final sub-circuit being tested is disconnected from the neutral link, and a 60-watt lamp is connected between the conductor and the neutral link. With one lead of the ohm meter connected to a known earth, the other lead is connected in turn to the neutral and earth contacts of the outlet. Correct neutral earth connection is proved when the neutral to earth indicates lamp resistance and earth to earth indicates a short circuit. Of course, circuits consisting of unlamped lamp holders can also be tested by this method. This test is necessary because a short circuit current flowing between live conductors can cause considerable damage. This is especially important in high current installations. Here, AS3000 requires live parts to be arranged so that short circuit or arcing will not occur under expected service conditions. Testing should confirm that any resistance measured between the active and neutral conductors of the circuit is consistent with the load. For example, on a socket outlet circuit with no connected equipment, a resistance in excess of 1 megohm should be expected, whereas a 4.8 kilowatt water heater circuit would be expected to have a resistance of 12 ohms. The testing is done with an ohm meter as follows. Between the live conductors of each individual single-phase or multi-phase circuit, with supply disconnected, usually by opening a circuit breaker RCD or fuse, with switches in the circuit on, and with portable appliances disconnected from socket outlets. This demonstration shows the use of an ohm meter connected between active and neutral conductors at the origin of a final subcircuit. This test is similar to and can be performed in conjunction with Test D, which dealt with the transposition of neutral and earthing conductors. Consider an installation where a live conductor from one circuit is used to connect equipment supplied from another circuit. Under normal operating conditions, it would appear to function correctly. However, a dangerous condition may be created when work is carried out on one of the apparently isolated circuits. Recognised methods of proving equipment or wiring to be dead may not be as effective, because in some instances, the dangerous condition will not become apparent until a neutral conductor is open-circuited. This condition may occur between circuits of the same installation or between different installations, for instance, multiple occupancy premises, such as shopping centres. Again, AS3000 generally requires a number of practices to be observed which reduce the risk of interconnection occurring. These practices include the sheathing of cables of consumers' mains or cables of different installations where they share an enclosure with other cables. Segregation is to be maintained between different systems, for example, low and extra low voltage, and testing should confirm that the wiring of each circuit is independent from that of other circuits. For this test, we need an ohm meter. Testing should normally be conducted between the neutral conductor of each circuit and all other neutral conductors, and between the active